This is 2003 AP Calc free response. Question 1, thus it's a calculator problem. It says right at the top, graphing calculator is required for some parts of the problem. All right. We have to start with seeing if there's a graph here and says let R be the shaded region of y equals the square root of x and y equals e to the negative 3x. And the vertical line x equals 1, as shown in the figure above. So without much thought, we should be easy to identify these three curves. Do we all agree? That's pretty easy for us to do. And it says find the area of R. Since this is a calculator problem, this should happen fairly quickly. But we have to find what I'm going to call point A, which I would use my graphing calculator, and I would put in the curve e negative 3x, and I would put in the curve square root of x, and I would just graph that intersection. And if I do that, all right, I'm going to find A is equal to 0.2387 is what I came up with.
We need to put 5 TIA.
And it's not a bad idea.
Here's mine. I get 2.244.
No, let's check it. Let's do it right now.
Yeah.
So now, once you have that intersection, this problem gets pretty easy, I think. And I'll get rid of the top stuff. I can just write now, I think this is the integral from a to 1 of the square root of x minus e to the negative 3x dx. All right, and now that integral is worth a point. You should be able to type this directly into your calculator. All right, and if you do that, and again, this is an older test, so it's got only 3 decimal places. It gives credit for these two answers. So it's a point for the integral and a point for one of these two answers. We go 4 decimal places. So I got to believe that it must have been 0.4426 is what, okay. Sounds like the consensus here is that we have this. That's a point. So here we are. We have 2 points. Now, if you have the correct limits throughout all your starts, and the correct limits are always going to be 0.2387 to 1, if you have that on all 3 parts, A, B, and C, you can give yourself a point. Okay? So that's the letter A, and we know there's going to be an overall point. So that means that there's only 6 points left for the next 2 parts, B and C. It is 3 points for each part. All right, part B says find the volume of the solid generated around the line y equals 1. All right, first of all, we have to picture the line y equals 1 here. All right, we're going to revolve around that. Now we know volume equals. All right, we know volume equals. I accidentally got a trailer here that I didn't capture to bring that up here. All right, volume equals the integral. Do we agree it's a to 1 this time? Of ax dx. And because we're going around a horizontal line, we're going to do this with respect to x. Do we agree? Now, when we look at this picture from these two things, I hope you notice there is an RO and an RI, right? Radius outside, radius inside. And again, the AP gives no credit for this, but I do write this personally. That way I never make a mistake. Because I want to catch what area I'm doing. And think of this as a ring. And now I have to define RO and RI, okay? I'm going to bring the pi out. Might as well do that now. And we catch the RO is this distance. Well, it's 1 minus the function, right? And have you guys caught it's always 1, it's always minus? I mean, again, we think about it, but it's always the same. It's something we can put as a memorized procedure here. Minus, what's the RI got to be then? Well, 1 minus the square root of x squared dx. The integrand is worth 2 points, all right? There's a whole bunch of minuses here. If you reverse these two things, you lose a point. If you have an error with the constant, that's not pi, you lose a point. Omit 1 and...
Eric Bennett, please report to the office, please. Eric Bennett,
If you forget 1,
Thank you.
you lose a point. All of their errors get minus 2. The point is we should be able to get these 2 points. And again, now what do you got to do? Just type it into your calculator. And again, we actually type this exact integral into our TA4.
What there is worth 2 points.
This whole thing is worth 2 points. And if you type this in your calculator, and again, this is an older test, it has to be between those two values. It must be 1.423. Is it 6 again? Holy cow! Look at that. That's worth a point. So that's a 3-point problem. And again, I would challenge that so far, these 5 points have been pretty easy. Find the region R and find the volume is easy. These are supposed to be gimme points. We group that, and we'll make it small. We'll start at the part C. All right. So now we get into part C. And part C says for the region R and is the base of a solid. For the solid, each cross-section perpendicular to the x-axis of rectangle whose height is 5 times the length of its base in the region R. All right, so now, again, it doesn't change this. All right, we're going to do the volume equals the area from, do you guys all agree, A to 1? And by doing A to 1 again, that gets the point for all three. Okay, AX dx. But this time, it is not a semicircle, and I'm going to get rid of all this blue from problem B here so we can look at the picture. Because now it says that it's a rectangle. And I'm going to draw a rectangle. And it has a length and a width. And it gives a relationship whose height is 5 times the length. Whose height is 5 times the length of its base in region R. I would call that meaning that this is 5W. All right? And this has to be W. Okay? Does everybody see how I came across that? This is the hardest part. All right? I draw this picture. We see that the distance in between here is W. All right? And we see the height is 5W. All right? So what is W then? How do I define that? Yep. So that's square root of x minus e to the negative 3x. That is W. Now, my argument, again, for what it's worth, the AP doesn't do this, but I would actually write width times 5 width. Do we agree? dx. And I think you can quickly discover here, right, that this simplifies to, can we bring the 5 out? Can we see that it turns into that? And again, once we integrate, or not integrate, once we substitute for W properly, what I'm writing right now is worth 2 points again. And I don't think this was that hard a problem to catch on with the rectangle. So there it is. Now you just got to type this in your TI calculator for the integral, 5 times, and again, 4 decimal places. When you do the integral, we're going to get 1.554 is what they have here. And again, older test, I don't know what the 4th decimal place is. We will go 4 decimal places. And this is the answer. And the answer is a point. So the integral right here is 2. The answer here is 1. And this is the 2003 question 1 result.